of you know some of these graphs already, but let's have a look anyways. Will I use degrees or radians? Which do you prefer? Degrees? Okay. So, let's say you want to graph this function, y equals sine x. I think some of you know this graph already. What's the biggest value on it? Someone knows this, I'm sure.
1.
Yeah, and the smallest, of course, then has to be minus 1. Okay. This is 0, and here is 360, 180, 90, 270. Well, what happened to you, Ming? Huh? What? Nothing. Ming. Okay. So the sine graph starts at 0, goes up to 1 at 90, back to 0 at 180, down to minus 1 at 270, and back to 0 at 360. And it repeats like this. It goes up, back down to 0, down to minus 1, and back to 0. Up to 1, and so on. And so on. And that is our sine graph. A basic, simple sine graph. Okay? Can you add that to your notes, please? Have you got that?
Mm-hmm.
Yeah?
Yes.
Okay. Now, let's have a look here. The next graph, y equals cos x. That will start at 1. It'll go down to minus 1 quite quickly down there. And then back, let me see if I got this right. I have to try that again. Come on, Bello. Sorry, I did that wrong. It'll go down to 0 at 90, then to minus 1 at 180, then back up to 0 at 270, and then back up to 1 at 360. So let me try that on the other side. Starts at the top. Down we go. And back up. So you see how the cos and the sine, they look very similar. It's almost like it's like you just moved them, isn't it? Yeah. Okay. Have you got that? Yeah? Yeah? Okay. I'm going to scroll down now. So what we're going to have a look at next is what about if we make some small changes? So, can I scroll down? Yeah. So the first one is, what if you have something like y equals sine x, but instead of graphing this, you graph y equals a sine x. So what is the effect of the a here on the graph? Does anyone know?
Height.
How does it change?
From 1 to 8. Like, the maximum would be 8.
Yeah, and the minimum?
Minus 8.
Yeah. So how would you describe this? if you describe visually how it changed. Hmm? Yeah, so like describe as if you had your hands and you could, you know what I mean? It's like you stretch it, isn't it? By A units. So I'll give you the graph I want you to draw here once it loads. Here we go. Okay, so I'll just draw y equals sine x. Okay, and now let me draw y equals, for example, 2 sine x. So before I draw it, can you picture what would it look like? It would go like this, up to 2, down to minus 2. Yeah? Let's see. Like that. Yeah. Can you add this picture to your notes? So you can write a little example here. This goes up twice as much. It's stretched 2 times. Okay. We got that one drawn? Yeah? Okay, now, the next one. Suppose you have now y equals sine bx. Does anyone know what happens here? Any ideas what happens? Yeah? More frequency, yeah. Can you describe with your hands how the graph changes? No, the opposite. It's not this. It's like this. It gets compressed. Yeah. If it's more than 1, yeah, yeah. Let me show you. You can draw this one now. So there's y sine x. So now this is y equals sine 2x. Before I draw it, can you visualize? I go like this, squish it. So let's have a look. You see? It's half. Yeah? So instead of finishing at 360, it finishes at 180. In the red, one period was 360, yeah? In the blue, one period is now 180. Okay. What if I had sine 3x? How wide would it be if it was sine 3x? Wide would it be? How wide? Not 60. 120. 120. Yeah? And if it was sine 4x? Be only out to 90. So instead of being 360, it gets squished to 90. Yeah? Okay, you can add this one now to your notes. We have 2 more to do, and then we'll do some examples. Okay, you got that? Yeah? Okay. Right. Y equals sine x. Actually, we usually write it as a minus c. Does anyone know what this would do?
Moves it left and right.
Which, in this case?
Right.
Yeah. It moves the graph to the right. So again, let me show you an example. Let's say I have y equals sine, I don't know, we'll move it like 60 degrees or something. Okay. So let me draw this. There we go. And let me draw this. Now before I hit draw, where's my draw button? Picture moving this to the right 60 degrees. So it should move a little to the right there. Let's see. See that? So you have to be careful with this one. The minus makes it move to the right. So it goes from red to blue. Okay, you can copy that one now. Okay, continue. Yes? Continue? Yep. So the last one is what happens if I have something like this, sine x plus d? Moves up, yeah, good. So let's draw that one now. Y equals sine x, let's say, plus 3. Okay, there's the first one. And before I draw it, can you picture? It'll be up 3 units higher. Up there. Moved up 3 units. Okay, continue. Yeah? Now, let's do our first example. Okay. I want to plot, let's say, y equals 2 sine 3x minus 90 degrees plus 1 between, let's say, minus 360 and 360. Yes, now these are actually a little bit tricky. I have a way of doing these which I like, and I hope you like too. So the first thing you should do is just take the 3 out here. So you have And you're always supposed to do this. So you have y equals a sine b x minus 30. So I took the 3 out. Close, close. Plus 1. So this is now our A, B, C, and D. Okay so far? Yes? Now, please watch carefully, because what I'm going to do now is make a table, very special type of table. Start, end, min, max. So sine normally starts at 0 and ends at 360. Its minimum is usually -1 and its maximum is usually 1. Okay? Yeah? Okay. Let's start with the A. What effect does the A have on the graph? What numbers will it change here? Good. What will they become? Right. Before I continue, is everyone okay with that? So I can put a tick here. Yeah? Tick. Okay. B. What's the effect of the B? Yeah, it shrinks it down. So it still starts at 0, but now? Very good. 120. B is good, yes? Right, what's the effect of the C? So moves it left or moves it right?
Right.
Yeah, so starts at 30, ends now at 150, and then -2 and 2 still. Okay. And finally, what's the effect of the D? Minimum and maximum change. By how much? 1. So this is 30 still, this is 150 still, and the minimum? Good, and the maximum? 3. Now, before I draw the graph, I'll let you write this much down. Yeah.
Like how do you get how did the minimum and maximum change?
In which step?
In the second one.
In this one here?
Like,
Because of the A stretches. So instead of going to 1, it'll go up to 2 because of the 2 here.
or isn't it meant to like affect the 3 and 32?
The 3 and the 30 here? No. These 4 are independent. They don't affect each other. So that's why I was able to look at them one at a time. Do you know what I mean when I say they're independent? I mean that I could make A 200 and it doesn't care. These 3 don't change and their effects don't change. You can look at them one by one by one by one. So earlier I gave you 4 graphs.
Yeah.
See, the first graph shows you what happens if you have an A. Do you see it?
Yeah.
What happens? It goes,
It goes on.
yeah, that's all that's happening here. So the 2 here, instead of going from -1 to 1, it now goes from -2 to 2. That's all that's happened. Anything else, guys? It's important that you get this.
Why do we have to take out 3?
Yeah, it's interesting because it seems like you should just be able to leave it.
Yeah.
But those 4 graphs I did, they only work if I can isolate the B and the C. It's kind of hard to explain. I didn't have to do this. It's just much easier this way. But if I kept it in here, it gets a bit more complicated. We'll actually study this in more detail in the second semester. We actually have a chapter on transformations.
Because 3s minus 90 is change every time, so it's a unit. So
you're saying, sorry. It's easier to have it like this. Ming, you don't have to do it like this. It's just in my experience, this is the easiest way to do it.
No, I'm trying to explain.
Yeah, go on, explain. Yeah. It's hard to explain maths in English, you know, when you're used to explaining it in Chinese. What do you think?
I think 3s minus 90 is the whole thing. It
What do you mean a whole thing?
Yeah, because it change
Yeah.
with s and I don't know.
Oh, I'm sorry, Ming. I'm so sorry. I don't understand what you're trying to say.
No. I confused myself.
Oh, okay. It's okay. Look, we'll continue with this and we'll see what happens, okay? Can I scroll down now? Yeah? Now look, the most important result is this one at the bottom. We'll use this to make our graph now. Can I scroll down? Yeah. Okay, so remember we want to be between minus 360 and 360. Okay, so let's make our graph nice and big. There's x. There's y. And we'll go 1, 2, 3, 4. Yeah? 1, 2, 3, 4. Right, that's 360. And that's minus 360. Now, I think I may need to go up in, from looking at this, I might have to go up in 30s. Okay? So if that's 360, then what's that one? 180. And this one? 90. And this one? 270. So this one, 180, 270, 90. Fair enough? And then in green, I can go 30s. So 30, 60, 90. 120, 150, 180. 210, 250, 270. 300, 330, 360. Messy. Okay. Minus 180, 180 there. 90, minus 90, minus 270, 270. Okay. Oh, and of course, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. All I've done now is just drawn a graph. Now, how to make our sine curve. So, watch carefully. Where are we starting here? At 30. Okay? So with a pencil, what you could do... Oh my goodness, okay. With a pencil, you can go down at 30. Okay, and then also down at 150, which is here. Yeah? 30 to 150. Now, how wide is this? That's 120 degrees, isn't it? Which is 1, 2, 3, 4 boxes. So, 1, 2, 3, 4 boxes. 1, 2, 3. The next one would be slightly outside, like over there. Yeah? 1, 2, 3, 4. Huh? 1, 2. What have I done? 1, 2, 3, 4. Yeah, that's okay, isn't it? 1, 2. Oh my goodness. 1, 2, 3, 4. Well, why are you saying about the minus 60?
Because you left and right with the 30 degrees.
Hmm? No, I think this is okay. I'm starting at 30. That's this guy. and I'm finishing at 150. That's this guy, isn't it? Okay, now next. What's the minimum value?
Minus 1.
-1. So, guess what I'm going to do now? Go across at -1. And the maximum? 3. Whoa. Nearly finished. It's getting a bit messy, I know. But can you see that I've made boxes here? 1, 2, 3, 4, 5, 6 boxes. Guess what goes in each box? A sign goes in each box. But how can we draw the sign in each box? Well, what we can do is make each box a window. Split it into 4. 1, 2, 3, 4. Okay, so... and down. I know, it's getting a bit complicated. After all that, we can now put the graph in. So let's go to the first box, which was 30 to 150. Remember, sine starts at the middle, goes up, down, down, and back to the middle. So can you see this window here? Can everyone see this window here? This window right here? You all look at that? Yes, you see it? So you start here, and you go up, down, down, up. Oh, whoa. Whoa. Okay. 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 Ta-da! Now, let's confirm that this is right. Okay. What was the graph I gave you? Y equals the original one? 2 sine 3x minus 90 like this. Okay. Where's it gone? Oh my goodness. Oh, come on, come back. Is it this? Oh, there we go. Look. Hang on. Look. Look. It's identical. You can't tell the difference. Mine? Yeah. Perfect. All right. You see, I told you these ones aren't. I mean, they're just a bit take a lot of time to do. A little bit messy as well. You need to have a pencil and a ruler and so on. Do your very no. Try to draw it.
Yeah, but I'll like standard, the correct one.
Oh, yeah, this is the correct one. Yeah, it's beautiful. I should sign my name to it. Okay, in the exam, I don't think they would like, it got a little bit here, a little bit off course. This is...
So in the exam we're using normal paper, not graph.
Oh, you have graph paper, yeah. Now, Bello, I should say, this is the most difficult question. Sometimes they just give you something maybe like this. Can you see? You know, but they have given you more complicated ones like what I've just done, but that is most difficult, maximum difficulty.
To delete after 360. Before in the question.
Yeah, it should really rub it out. Yeah.
You started from 0.
No, I started from, what was this?
Started
30?
from 0.
What do you mean I started from 0?
Like you have to start from 30.
I start from 30. This is 30.
From up or from down? Then?
From the middle. Remember, sine goes like this. So it starts in the middle. So this is 30 and it's the middle of the sine. Does that make sense? This is not at 0. It's a little to the right. It's 30 degrees to the right.
I don't know. 'Cause, like you have to start from 30.
I have to start from...
down.
Oh, from here?
Yeah.
No. But look, the computer agrees with me.
It's from 30.
Where's 30? 30 is...
No, yeah. I
This
draw
is
the same
30.
as this picture. Yeah. You said 30.
No, this is 30 here, isn't it?
No,
God,
down.
Hey. Hey.
This is 30 here, isn't it?
Yeah.
Yeah.
And this is 1 unit.
Yeah, you have to.
I have to start from here. You think I should start from here?
Yeah.
No, I don't accept that. Let me
You
see.
have to.
Let's check. 30 degrees is pi over 6, isn't it? Isn't that 30 degrees?
Yeah.
The same
Yes.
as this graph.
Oh, hang on, let me mark off 30 degrees first. Now, look, Aoife, look. This line here is 30 degrees. And you notice how it starts here?
Oh yeah, but the graph.
Or maybe it cuts here at like 15 or something. I'm not sure. And I know I'm a little bit messy, so if you want, it's maybe more like that. And here could be 15 perhaps. But it definitely starts in the middle at 30 and goes up, down, up like that. Yeah. Yeah, the plus 1. That, yeah, lifts it up. Yeah. All right, are we okay with this now?
No.
No. What's wrong? Is it too beautiful? It's too beautiful. Yeah.
Beautiful.
Yeah, too beautiful.
Sorry, how did you
Yeah, Mona Lisa. Yeah,
How did
exactly.
you
Yeah.
get the grid again?
Which grid?
Like the grid you made the boxes.
From the numbers here.
You did 30 first.
30, 150, minus 1, 3. Yeah. You drew this already? Yeah. All right. Have you got that? Can do? Well, the next thing to do is give you questions. Okay, I'll be nice to you. I'll just give you 2 questions to do. Okay? 1A and 1B.
One A and B.
1A
M.
and 1B. Okay, we can do it on Friday in the tutorial. Make sure you ask me on Friday. Don't skip this class. Yeah, okay. And don't be late. Oh, thank you. Okay, can I close this work of art? Yeah.
One A and two
Oh, one, no, 1A and 1B. 1A and 1B. First two.